Hello and welcome back. Today we're going to be setting up some basic AI, placement, spawning, and a little bit of aggro systems, but nothing too complicated on that just yet. So we're going to be starting out with a couple of changes to the cultist. We went ahead and removed the set target script up here on the cultist itself, as we'll be replacing it with a proper AI script here in just a second. Now the limb placement controller is going to be referencing the basic enemy navigation agent over here. We're going to be changing this up slightly though. So let's go ahead and hop into code and get started. So first off, on the basic enemy navigation agent, we're going to go ahead and remove a couple things. We're no longer going to need to keep track of the player, and so we're just going to go ahead and remove that right there, and that should all just work fine. Now the limb placement controller over here is going to whine because it doesn't have access to a player target, but we'll get back to that in a moment. First off, we need to go ahead and create an AI controller script. So we're just going to do that in the enemies folder here. We're going to create a new script, and it's going to be named EnemyAIController. And we're just going to inherit from node 3D right there. And let's go ahead and create that. We'll go ahead and double click that. And first off, let's create a couple exports. Now we're going to need a wander radius as well as a boolean saying whether the wander radius can be updated. So we're going to go ahead and create a new export category right here. The allow movement of wander center is just going to say if we're told to go somewhere specifically, do we want to wander around that destination or do we want to wander around our original destination? So we'll implement that in a moment. But first off, let's go ahead and add in another category for the target tracking settings. Now we're going to have target movement bias as well as a navigation agent reference and the current target reference. The target movement bias is just like we used in the basic enemy navigation agent originally. It just is to make sure if the current target has moved a little bit, we're going to update our path towards it. Now besides that, we do need a public variable for the wandering position, and that's going to be the position that we wander around using the wandering radius, and we're just going to leave it accessible so that way we can access it from other scripts and manipulate that later on for various reasons. Now besides this, we do need to go ahead and create a target overwritten boolean and a target override vector 3, and this is just going to be to override the wandering and the current target tracking and just basically tell the AI to go to a specific location, forget everything else. Besides that, we do need to go ahead and keep track of the last target position, and that's going to be the last time we path towards the current target. That way we can use it to reference the target movement bias to see whether we should repath again. All right, now first off, we're going to go ahead and start in the process function, and we're just going to check to see if the target overwritten equals true. So that means we want to override all the other pathing. And we're going to go ahead and put a return in here so that way it doesn't continue after that. And first off, we're going to check to see if the target position does not equal the target override. Go ahead and set the target position to target override. Now, the reason why we don't do this every single frame is because if we change the target position, it goes ahead and updates the path and repaths. So we just want to execute it once whenever necessary. Now, if it has already set the target position, we're just going to go ahead and check to see if the navigation agent's navigation is finished. And if so, we're going to do a couple things. First off, we're going to set the wandering position that we're wandering around to the target override if we're allowed to move the wander position. And then lastly, we're going to go ahead and set our target overwritten to equal false. And that'll pretty much handle it for the target override. This is pretty simple, but later on we'll be able to use this override to move around during combat or to go into cinematic modes and move around specific locations. Now, if we aren't currently overriding, we can go ahead and check to see if the current target does not equal null. And if the current target does not equal null, then we're going to go ahead and do a pretty simple check for the distance of the current target to the last target position. And if that's greater than the target movement bias, we're going to go ahead and update our last target position and update our target position for the navigation agent. And then of course, we're also going to be returning out of that as well so that we don't continue onwards. Now, if we aren't overwritten and we don't have a current target, we're going to go ahead and check to see if the navigation is finished. And if it is, then we're going to set a new wander position. Now, we do need to go ahead and create the function for a new wander position. Now, this function is going to set a direction randomly, then normalize it and scale it between a float between 0 and wander radius. And it's actually going to be doing that by scaling a float between 0 and 1 and then multiplying it by wander radius. So first off, we're going to go ahead and get a random number generator and we're going to randomize that. Then we're going to create a new wander direction. Now, the wander direction is going to take in the RNG randf range between -1 and 1 for the X and Z axis and leaving the y-axis alone. I don't want to try and select a target position that's up in the air or outside of the cave or something like that. We just want it in a flat plane around the AI. Then we go ahead and normalize that so it always has a length of 1. If we didn't do this, it would actually look more like a square and not a circle. And then we're going to multiply that by randf, which is just between 0 and 1, multiplied by the wander radius. And finally, we're going to go ahead and set our navigation target position equal to that wandering position plus the wander direction. It's not exactly elegant, but it certainly is simple and it gets the job done. Now up here before the process node, we do need a couple functions that are going to help us in spawning the AI and using it later on for repositioning and stuff. So first off, let's go ahead and create a placeOnMesh function. And this is just going to handle snapping to the nav mesh. And all it's going to do for that is set the wandering position to equal the current global position. And then it's going to set the target position equal to the global position. And that's going to trigger a path rebuild. So I was about to tell you that this doesn't actually work unless you delay for 1 frame, but after working with it a little bit, I realized that I was actually solving a problem that I found elsewhere in the setup. So all of this is unnecessary. You can go ahead and set the global position to the navigation agent's final position. You don't have to await anything, and you can remove that async void. I found out down here where I'm setting the current target for the enemy, if I happen to set the target before the placeOnMesh, then the end result is that it will teleport to the player immediately upon spawning. Obviously not ideal. So this is the correct code. We're going to jump back into the previous recording. Obviously it'll be a little bit different, but just bear that in mind. Now besides that, we're going to go ahead and create a new function for the set node target, and this is going to set our current target up here, along with an option to override the targeting pathing, that's the target overwritten right there, in order to wipe it out if we want to make the aggro override whatever it was last doing. In the case of, say, aggression from the player towards the AI. This will snap it out of whatever its last path was if we happen to set that to true. So we're going to go ahead and check to see if we are currently target overwritten and the override targeting pathing equals true, then we're going to set the target overwritten to equal false. And that's just going to clear out that override. Then we're going to set our current target equal to the new target. Now there is one last function, and that's set pathing target. And this is just going to be setting that target overwritten. So first off, we're going to check to see if the target does not equal null and the override aggro option is not equal to true. So the override aggro here will allow you to just ignore the current target. But if the target does not equal null and that does not equal true, then we go ahead and return right away. We don't actually set the pathing target. However, if that's not the case, we can go ahead and set the target override to the target position and the target overwritten to equal true. And this will just go ahead and knock it out of whatever its current target is into the designated location. And that's pretty much it for this. Now we do need to go ahead and create a spawning script. So first off, in the enemies folder, let's go ahead and create a new script for the enemy spawn point. And we're going to inherit this from Marker 3D. And within here, we're going to have a couple very simple options. We're going to have a pack scene for the enemy pack scene. Now, besides that, we're going to go ahead and create a new function that's going to be called anytime this spawn point is used. And it's going to be referencing a node 3D as a parameter here with an underscore as the name. This just goes ahead and discards that node 3D. The reason why we're doing this is because we're connecting it to a signal from an area 3D, which happens to pass a node 3D of the body that entered into the area 3D. And so as a result, I just went ahead and made it in this way so we can connect up the signal directly and don't have to do any weird stuff with it. Now, in order to instantiate the AI, we're going to do a couple things. We're going to first off instantiate it as an enemy AI controller, and then we're going to go ahead and take the parent of this spawn point and add the child of the new enemy to it. Then we're going to go ahead and set its global position and global rotation to this spawn point's global position and global rotation. Finally, we're going to go ahead and use the placeOnMesh function that we created earlier, and that's going to go ahead and take care of its actual positioning. We're going to go ahead and set the target if the auto set target equals true, and that's pretty much going to handle it here. We are going to go ahead and add the decorator for the global class up at the top in order to make this just right-click spawnable in the editor. Now there is one last little thing that we need to do. We need to create a helper function for the actual volume trigger, and we're going to create that in the helpers function. So I'm going to call that trigger volume and inherit from area 3D, and that is going to be a very simple script. All it's going to do is have a single function that's going to take in the node 3D in order to be able to be hooked up to a signal, and it's just going to queue free this area 3D. I just found that this is just the cleanest way to get it working. Now, when I tried to build, I did go ahead and get that error. The basic enemy navigation target is not currently in the limb placement code, so we do need to go ahead and update that. Just above the basic enemy navigation agent, we're going to create a new export for the enemy AI controller, and we're going to copy that and replace these enemy body locations with that, and then use the current target instead of player target. And that should work. If we go ahead and hit build, it should just work just fine, and we can go ahead and hop back into Godot. So over here in Godot, there's a couple new things that we need to do. First off, we need to add the AI controller to the cultist. And we can go ahead and assign that in the Enemy AI Controller option in Limb Placement Controller. Now over here on the cultist, we do need to go ahead and set up the navigation agent and leave the current target to nothing. I'm going to leave the target movement bias to 1. Now over here in the scene, I did go ahead and create a new spawn volume, and this is just of type area 3D with a collision of a cube underneath it. We went ahead and created this down the path from the player, and we positioned it in such a way that the player cannot proceed without it hitting it. Now just above that in the triggers, we can go ahead and add a child for the enemy spawn point. And after we move it over here to where the spawn volume is, we can go ahead and place this over here in a very noticeable location. Later on, we'll obviously want this around the corner or something, but just for now, in order to test it, we'll go ahead and place it right here. So we'll save that, and we do have our cultist prefab. We can drag in the enemy pack scene. We're going to leave the auto set target off for now. And over here on the spawn trigger, we do need to go ahead and set a couple triggers. So body entered, we need to connect up to the enemy spawn point, and we'll select the spawn initiated function. Then we'll go ahead and hit save. Now on the spawn trigger volume itself, we do need to go ahead and assign our trigger volume script. So we'll go ahead and do so there. Now we can select the signal and select itself and select the trigger volume underscore body entered function. And that's just going to go ahead and queue free it when it's done. And that should be pretty much it. Let's go ahead and hop in game and see how it looks. All right, and we're in the corridor here. If we go ahead and walk into the collider now, you can see an AI has spawned. Obviously not exactly the most graceful, but always make sure that regardless of the situation, you don't spawn AI directly in front of the player if possible. Now, later on, we probably would want to work in some sort of particle effect or something so that if the player does happen to see them spawn, it looks more like they're appearing, like teleporting in or something. That's a problem for another day. For now, everything looks pretty good. We're going to go ahead and leave it there. Next week, we're going to be working on actual targeting, acquisition, and death of the cultist. So we'll see how that goes. Thank you all for watching. As always, I'm very glad I managed to get OBS to actually cooperate now, so everything should be a little bit smoother now, and hopefully the videos will be a little bit better in the future. But as always, thank you all for watching. I hope you all have a wonderful week, and we'll see you all back here next week for the next tutorial.